Okay, so in this video we're going to take a look at a Charles gas law problem. I won't always identify the gas law that you would use to solve a problem, so I'm going to start by solving this problem. First of all, identifying which gas law I need to use, and then show you how to solve it. So as I read the problem, it says a sample of nitrogen occupies a volume of 450 milliliters. I like to just stop as I'm reading the equation and kind of box in or underline each one of my variables. I know that milliliters is a unit for volume, so I'm going to label that as my volume 1. And here's the temperature that that sample of gas was at, so there's going to be my temperature 1. I know that's temperature because it has the unit degrees Celsius. It says what volume, that to me means my unknown is going to be volume 2. Will it occupy at 105 degrees Celsius? There is my ending temperature. So as I read this problem, I'm given just a little bit of information. I'm only given volume and temperature. This problem says nothing about pressure, so I can assume it's constant. And this problem says nothing about moles, so I know I'm not going to use the ideal gas law. So what I like to do is write out the entire combined gas law. P1 V1 over T1 equals P2 V2 over T2. And then I'm going to assume the variable pressure is constant. Why? Because this problem doesn't say anything about it. So if I cover over my pressure variable, I can magically see the correct equation appear, which we've already identified as Charles gas law. Charles gas law states there is a direct relationship between temperature and volume of a gas using temperature in Kelvin. From here, it's just a simple plug and chug situation. What can I plug in for volume 1? Well, we label that as 450 milliliters. Put that over temperature 1. Please do not make my favorite mistake. If you accidentally put 30 degrees Celsius down here, please cross it out with a big fat X. No, no, no. You must convert to Kelvin. So how do I convert to Kelvin? It's very simple. All I did was take 30 and add 273. To convert from degrees Celsius to Kelvin, you must add 273. Continuing, my volume 2 is unknown. And again, don't make my favorite mistake. If you accidentally put 105 here, please cross it out. You cannot use degrees Celsius. You must add 273 to get Kelvin. You should end up with 378 Kelvin. Okay, so now I'm all set. How do I isolate and get V2 all on its own? I like to cross multiply and then divide. So it helps me out if I circle in the two that are across from each other. Punch in your calculator 450 times 378 divided by that remaining number that's just kind of hanging out. So divide by 303. For volume 2, you should end up with a final answer of about 561.4. And my remaining unit is milliliters because Kelvin will cancel out once you divide through. And depending on how you round, yours might be a little bit different from mine. But again, how did I get that answer? Cross multiply and then divide by 303. And again, you can also kind of double check and see how you're doing based off of the relationship that's seen in Charles gas law. We know Charles gas law is a direct relationship. That means if temperature goes up, pressure also, if temperature goes up, volume also goes up. So let's take a look at our temperature here. What happened to our temperature? We started at 303, we ended at 378. Well, my temperature clearly went up. Let's check out and see what's going to happen to my volume. We should have a direct relationship and my volume should go up. Did we calculate a value that was higher than our starting value of 450? Yeah, our volume in this case did go up. So we probably got the correct answer because using Charles gas law, we know there's a direct relationship between temperature and volume. This has been a Rodriguez original production. I hope you enjoyed it. Go back and study, do more example problems. Good luck.